Hi and hello there. Welcome to the new video of the course, and in this particular video we are going to see the symbol and construction of BJT transistor. So in this particular in this particular lecture we are going to see symbol and construction of bipolar junction transistor, or BJT in short. BJTs. Let me just take this particular thing somewhere over here and highlight it, and then we are good to go. Yes, let me just highlight this whole of the things. Symbol and construction of BJT or bipolar junction transistors. Okay, and as we all know, as we had seen in the previous video, that a BJT transistor is further divided into two types. That is, the very first type, or the very first part, is NPN BJT transistor, a bipolar junction transistor. Right, so now we will see that why it is known as NPN transistor. So for that, what I am going to do, I am just going to draw this particular thing, and once if I draw this particular thing, then you will get a clear-cut idea of what I want to conclude to you all guys. Let me take a blue color. I'll draw maybe somewhere over here. Yes, this is what I meant. So basically what you are doing over here, you are taking one N region, okay, and again one N region, but in between both of them you are sandwiching what? You are sandwiching one P region, or basically you are putting one P region over here. That means what? P region is sandwiched between two N region, and that's why it is known as NPN transistor. I hope now you are very much familiar with N type and P type semiconductors, because all these things we had studied in the previous courses. That means in the second and third course, where in the second course we had deal with semiconductors, and in the third course we had seen the what exactly happens when we sandwich P and N junctions, right? And how these particular electrons and holes they travel or they migrate and all. I hope you right now you are very much familiar with this particular concept of depletion region and all, because now we are going to use this particular concept again and again very rigorously in this particular transistor, that is BJT transistor. Okay, so if you are not familiar with that particular thing, I will request you all guys to please watch my previous courses, or please do enroll the previous courses. Otherwise you will face difficulties in this particular topic. Okay, so what you are doing over here, as you can see over here, there are more number of electrons. Obviously this is what we had seen in the semiconductor as well. N type has more electrons. Okay, I'm just drawing very few as of now, whereas P type has very few electrons. Okay, P type has very few electrons, and this is again N type, so it has again a more number of electrons as compared to P type. Okay, whereas P type has more number of holes, so these are the holes. P type has more number of holes as compared to N type, right? And N type has very few number of holes. Over here as well, very few number of holes, and that's why it is known as NPN transistor. Okay, and let me just take 3 electrodes out from this particular NPN transistor, and then we will see certain things. This is very first electrode, this is second electrode coming from the P type, and this is the third electrode coming from the N type again. Before coming to this part, now if you could see very clearly over here, you can see that area of this particular N type region is greater than this particular N type region. As you can see, let's suppose if I'm considering that area of this particular N type region is A1, okay, and this particular area of the N type region is A2. So as you can see very clearly, A1 is greater than, A1 is greater than A2. Now you will say, sir, you had done this by mistakenly. I will say no, I had done it intentionally, because this is how a BJT transistor looks like. So when the area which is greater than the another area, considering that both are N type, so this particular area or this particular region, it is known as collector region, or basically the electrode coming out from the area which is greater than the another area. For N type I'm talking, so this particular region is known as or this particular terminal is known as collector or C. I'm just right now I'm just indicating. I'll just want certain different color. Yeah, maybe the so this particular electrode coming from the A1 or from the area A1, it is known as collector, right? Whereas this particular electrode which is coming from the A2, that means the second area or the area 2, it is known as emitter, or I will just indicate it with E. Whereas this P type region, it is known as base or B, right? So this is how an NPN transistor looks, or this is how the internal structure of NPN transistor looks like. Okay, further we are going to study this particular thing in great depth, but as of now you just have to understand this particular part. Okay, that why, like why the area 1 is greater than area 2, we will study in the next videos, in the upcoming videos. But as of now, you just have to know the, or you just have to be very much familiar with this particular concept, that okay, the larger area is known as collector region, the smaller area is known as emitter region, and the area which is present or which is very much small, and basically it is P region, it is known as base, right? And now we will study the symbol of for this particular transistor. So let me draw the symbol as well. uh, just a second, I will draw the symbol. So this is how the transistor will look like. Maybe I will take certain different color. Yeah, I think purple will be good. So this is how the BJT transistor is going to look like. Just a second. Yeah, maybe something like this, and then over here, and then what, and then something like this. So this is how our NPN transistor is going to look like. Okay, so this particular region, as you can see over here, or this particular electrode, it is known as C. I'll write over here C, that is collector electrode. Okay, and I just forgot to draw this particular thing out over here. This is known as base, and let me just draw a small kind of dot, or indicating that these are the electrodes of this particular transistor. Okay, and then we will see each and everything. Yeah, and this particular thing over here, this is the base of transistor, indicating as B, indicated as B. B is indicated as base of transistor, right? And this particular thing over here, this is known as E, that is emitter of transistor. I hope you are getting my point. And now you will tell to me that, sir, why we are indicating this particular arrow, like arrow is indicating like arrow has been indicated such that it is coming out of this particular terminal. That means it is the arrow is coming out of the emitter junction, right? This arrow is coming out of the emitter junction, something like this. Yeah, your guess is absolutely correct. This arrow indicates that it is a current coming out of the transistor. So that's why NPN transistor, to remember in very short form, it is also known as or basically mostly in the colleges, professor target NPN as will take certain different color. Yeah, I'll target NPN as not pointing in. As such, there isn't any reason for it, but yeah, this actually helps to understand student or to remember the things. Okay, so students could remember this particular thing, and that's why they target this particular point. Like NPN is known as also known as not pointing in. Okay, see, as you can see, the arrow is not pointing in, it is coming out of this particular what I can say transistor, or basically it is approaching towards the emitter electrode, right? That means what, this is the current is coming from the emitter, or the current is coming towards the emitter electrode, and that's why it is going out. This is what we can say, na? Like the current is going out of the transistor, that means it is coming out of the emitter region, right? It is coming out of the emitter region, and that's why we are saying it as not pointing in NPN transistor. This is the another way you can remember this particular uh, name of the transistor. I hope you are getting my point. Okay, so now we will move forward and then we will see the PNP transistor. Let me take this color. Yeah, now we will see PNP transistor. PNP transistor, BJT transistor, or bipolar junction transistor. By now I hope that you might have guessed that how this particular transistor is going to look like, and how I hope that your guess is absolutely correct. Again, what I will do right now, I will take a blue color. Okay, something just a second. Yeah, something like this, right? And then I'll just draw N region over here, N region over here. So this is your N region, and obviously over here this is the area 1, A1, A1, this is A2, right? And as you can see very clearly over here, A1 is greater than A2, A1 is greater than A2, both are p-type regions. In this particular case, both are p-type regions. That means what? That means there are more number of holes, okay, and very few number of electrons in this particular region. So very few number, hardly 1 or 2, right? Whereas in this particular region there are more number of electrons, and very few number of holes, as you can see over here, very few holes and more number of electrons, right? And over here as well, in this particular region you will see more number of holes, right? You will see more number of holes. And as I told to you, since A1 is greater than A2, so this particular area is known as collector area, and the electrode coming out from this particular region or this particular area, it is known as what? It is known as collector. Similarly over here, this is the base region, and this is the emitter region. I hope you are getting my point. So I'll just mark it as C, indicating that it is a collector region, or basically collector electrode. This as base electrode, and this as what? This is emitter electrode. Just a second, E. And now what we are going to do, again we are going to draw a symbol of a transistor. So for that I'll just draw it very quickly so that we do not waste most of our time. So this is how it is going to look like, and then over here the arrow will come towards the transistor, something like this. Yes, and then we are going to draw this particular transistor in this way, and this one in this way, and this one in this way, right? I hope you are getting my point. Let me just bring this particular thing somewhere over here. Let me just draw this particular dots, indicating that these are the electrodes of these particular transistors, and then we are good to go. Okay. So now as you can see very clearly, let me take certain different color, maybe yellow one. Yeah, this is the C, collector region, indicating that this is the collector electrode, right? This is B, indicating that this is the base electrode or the base region of the transistor, and this is E, indicating that this is the emitter or emitter electrode or the emitter region. So now if you could see very clearly over here, the current is coming outside. We will see that how it is going to come outside and how it is going to go inside the transistor. You need not to worry about this particular thing as of now. In this particular in this particular video, you just focus on this particular part. The arrow is coming out, that means what? The current is going to move in this particular direction, right? And in this particular symbol, like in PNP transistor, the current is moving in this particular direction, indicating that current is coming towards the transistor. Okay, and over here in the very first case, the current was moving out of the transistor. I hope you are getting my point. Let me just erase this particular thing, and then we are good to go, or good to proceed further. Okay, and over here as you can see, P and P, I will write over here P and P. So over here we just have what I can say, words for these two particular thing, that is PNP can also be known as pointing in, pointing in, pointing in, and as you can see the arrow is pointing towards transistor. That means in inwards direction. I hope you are getting my point. Pointing, oh sorry, pointing in PN, the arrow is pointing inwards to the transistor, and whereas over here, if you could see very clearly, NPN, that means what? The arrow was not pointing inwards, it was pointing outwards. This is what it means. And now I hope that you had understood the construction and the symbol of this particular BJT transistors. Okay, so I'm ending this video over here. Thank you.